We get calls often about the Racepak Smartwire and why we use it and why we recommend it, and just about every car that we do. So I figured I would give you guys a look at how to use the Racepak Smartwire software and its versatility, and as to why it's one of those things that we recommend and that we use in as much as we can. So first thing we're going to do is open up Data Link software from Racepak, and this can be downloaded off of the website. So just double click it, and this box will pop up. This is for older Racepak V300 stuff. Just hit cancel. So what we have here, I'm just going to maximize the screen. What we have here is what I set to the default config to pop up every time I open it, which is my own personal car. So what we can do is we go File and Open Car Configuration. We have a list of a bunch of different cars. So once you build a car config, it'll pop up in that list, and then you have the ability to make that car config your default. So let's assume that you've figured out how to do that, and you've already downloaded from the SmartWire. To download from the SmartWire, what you do is hit Read when you're plugged into it, and you have all your CAN bus devices plugged into it as well, say a switch panel, a keypad, whatever it may be. And you hit Read. It'll populate all of this stuff. The reason that we have these things that list EFI right here, basically from here and back, is because there is a EFI to CAN bus module. So it's one of the universal CAN bus modules from Racepak. It's not a necessity. It just adds a little bit more flexibility. So I'll show you how to do some stuff with this thing without that, and then again with it. So, but what our real focus here is basically from here on, right? So this is my own car. These are our outputs, right? So I have them labeled A3 transfin, A6 internal dump, yada yada, right? So when you look at this, it's just when you first populate it out of your car with nothing loaded in it. All these are just going to say input one, input or output 1, 2, 3, 4, 5, blah blah blah. You rename them. So let's look at like this right here, A4, and I'm going to right click on this, and it populates this window. So these are the output parameters. So this is where you can change the name, right? So I just named it pin number. I always like to put the pin number first, right? So A4 high beam. So this is the output for the high beams. So the a couple things on this screen, we'll go over them step by step. Channel mode enabled. So obviously if we disabled it, it would shut off that channel, and we wouldn't be able to do anything with it. This stuff is irrelevant. Fuse current, this is where you set the fuse for the output. So if the high beams were going to draw a lot of whatever amperage, you can set the fuse current here. And then we go to fuse reset delay. This stuff again is irrelevant, but fuse reset delay. So this is if it pops a fuse, as in if the high beams drew 10 amps, or over 10 amps, it would pop the fuse. And then we have a delay to reset the fuse. So it automatically resets the fuse. So we wait 1 second, and then it resets the fuse, and it'll reset the fuse up to 100 times. Okay, so that's kind of a neat feature, because if it's on a water pump or something, it can just continue to reset that fuse over and over again until you kind of realize, like, hey, we got a problem, pull over, as opposed to just shutting the thing off. Over here we have output function, so constant on. We have the ability to do flash, latch on, windshield wiper, or single pulse. I'm going to show you what flash does when we look at the turn signals as well. But constant on means you want it on whenever it's turned on. You can ignore this stuff. And then you also have the ability to put an on delay time, right? So if you hit the high beam button, you can make it wait 5 seconds before it actually turns the high beams on. So in here, on conditions is where we're going to program it as to why it would turn on, how it turns on, right? So if we click on this on condition, I have it listed here as just KP2 high beams equals 1. So I got that by doing this. So we'll just do this, together, right? So we just click on this little down arrow, and it populates all of these things, right? So these are all of our, here's all of our EFI parameters from that universal CAN bus module. And then these are our outputs. So if we wanted the high beams to come on with an additional output, we can do that. But I like to do it based off of inputs. So I've relabeled these as hardwire inputs, keypad 2 and keypad 1. So this is a keypad 1 or keypad 2 in my car. I've got a high beam switch. So keypad 2 high beam is equal to 1. Equal to 1 means that the button is on. Less than 1 would be the button is off, or equal to 0 is button is off. Okay, so that's a basic setup on how to do that. Once you have got that programmed, that's simple, on off, you would hit send configuration. Okay, once you send the configuration, it is now programmed to the Smartwire. You go over there, hit your keypad 2 high beam button, and the high beams come on. Now, kind of jumped around a little bit, but let's look at how to set up the keypads and the hardwired inputs. So we right click on keypad 2 and it populates a little picture of the keypad. So the keypads can be set to either momentary or like latching, right? So right here, you change your switch type from toggle to momentary if you wanted to. And then the status ID is this light right here, right? So the lights will turn on based off of if that output is on. So this one is park lights, and the status ID is based off of the marker light. The marker light, when A7 is on, we have a status light that comes on. Okay, this is a blown fuse light. So if it blew a park lamp fuse, this would flash red. Or if there was an error on the channel, if the channel was supposed to be on but wasn't on, that would flash red. Okay, so these are pretty self-explanatory. What you want to do is you want to name these something so they make sense, because this is what you're going to be finding in your on conditions list. So these are all toggles. Cancel. Let's go over to keypad 1 left hand side. So right here, here's a momentary. The starter is momentary, right? So the starter button is a momentary. So we just change that over to momentary, and the status ID is going to be starter. So if the starter is engaged, we'll have a little light that comes on. So let's look here, right? Water pump, right? Water pump I have turned on based off of the fuel injection system, and I have a button for it, right? So like if I want to run the water pump with the key on engine off, or no automation from the ECU, I can just press the button for water pump, even if the ignition's off, right? I can just press the water pump button and it'll run the water pump. If I don't press that button, the little green light is still going to come on when the ECU tells it to turn on. So don't be alarmed by that. Just know that it's being told to turn on by an outside source, because the status ID means that it's following B15 water pump and it's on. Same thing for fans and trans fan and all that kind of stuff. So that's how you set up a keypad. And then when you're done naming all of this and deciding its status ID, hit send configuration and then hit OK. The other input side of things is hardwired inputs. It'll say, I believe, SM1 inputs. So just right click on SM1 inputs. So these are hardwired inputs into the Smartwire. Those inputs can be either 12 volt or ground, and they can be momentary buttons on the the steering wheel or on a roll cage or something. They could be your factory turn signal switches. They can be your factory ignition switch. It can be whatever you want them to be, right? So for my own car, because we've got an EFI CAN bus module, we don't really use a lot of these, right? So what I did was, the ones that we did need was neutral safety. So from the shifter, I needed a neutral safety. Bump start buttons. What that means is there's a button underneath the hood to run the starter. So if I want to lash valves, I threw 3 spare outputs from the ECU to be inputs to the Smartwire. I've got a fuel pump from ECU, internal dump from ECU, and injector from ECU. So, and I'll show you how those work from the Holly software. But what this is you can change them, whether they be ground or voltage inputs. No matter whatever they are, this is where you set them up. And then these inputs will be used as on conditions for your outputs that turn on, like your high powered outputs that turn devices on. So let's just look at the B13 fuel pump from ECU, right? So hit OK. Let's go to the configuration in the Holly software. So hopefully you guys are familiar with this. We're in the IO ICF. We hit output, and let's find 93 fuel pump SW Smartwire, right? So we hit configure, and when injector coil loop is enabled or RPM is above 50 RPM, right? So That means that this output goes live, right here, 93 fuel pump from to Smartwire. This is an output from the ECU from J4B3, and it goes to a hardwired input of Smartwire connector B pin 13. Okay, so it's sending a 12 volt signal out from J4B3, and the wire is sending 12 volt over to the Smartwire connector B pin number 13 right here. Okay, all right. So that's how it works. You just set these outputs up, your hardwired outputs up. Like here's my spares, right? So here's spare 1, 2, and 3. They go out and send signals out to spare 1, 2, and 3 from the ECU. These are spare inputs that I have that are actually mounted up underneath my dash. So if I ever decided to add some stuff, I could just plug right into them. So those are our inputs. Inputs are usually the first thing that you need to program in the SmartWire because your all of your output on conditions are based off of inputs. So you need to know where they are in order to select them, right? So let's look at a couple of little oddball ones, right? So let's look at that fuel pump, right? So fuel pump 1, it's enabled. Our on condition is fuel pump from ECU is equal to 1 and the ignition switch is on. Okay, so if you turn off ignition, obviously the fuel pump from ECU would go dead as well. It's just kind of a redundant thing. But fuel pump from ECU is equal to 1 and it'll turn on that fuel pump output. Now notice that I've got fuel pump 1 2 times, right, on pin B1 and pin B3. And that's so that we can give it the amperage capacity of 40 amp, right? So fuel pump 1 on B3 is worth 20 amp. And then we can join that, right, to on B1. That one's also worth 20 amps. So we have 40 amps available to power those pumps. That's total overkill for this application because they're Walbro 225s, but I'd rather it be overkill than not enough, right? So the way this wired up was I ran a wire from B1 and B3 all the way back to the fuel pump connector, and I joined them at the fuel pump connector. And when the output goes active, they both go active together, right? So the on condition for this one is fuel pump, right? So we're looking at B1 up here, B1 fuel pump 1. When fuel pump from ECU is equal to 1, it's on. And we look at B3, and the on conditions, even though they're in reverse order, it doesn't matter. Both of those have to be active in order to do that, right? So if we wanted to remove something from there to make it active with just ignition, say we just turn the ignition on and we want it on, we would right click in this box and we could remove one of them, right? If we wanted to add an additional reason for it to turn on, we could go hardwired inputs and let's just say neutral safety, right? We could right click and say, hey, neutral safety equal to 1. I mean, it makes no sense, right? Because obviously, but it's just the first thing I saw. If you wanted to have a secondary reason to turn on that fuel pump, you could go keypad. Right here, we could say the boost switch for the keypad is equal to 1. And we could hit this right here. We could right click down here and say keypad boost switch is equal to 1, and it now turns on that fuel pump. So that fuel pump will turn on based off of the ignition being on and the fuel pump from ECU trigger being equal to 1. Or we just press the boost switch and it turns on the fuel pump. So this is where you have options for turning it on, and this is where you get way more flexibility than just some relays and whatnot, because you have the ability to turn this stuff on and off however you see fit. So there's a reason it's called a smart wire. You have to be reasonably intelligent to understand how to use it. Not really smart. You don't have to be really smart. You just need to be, have to think a little bit in order to use it to its fullest. So let's look at the starter here, right? So I'm going to right click. I'm going to hit on condition. This is a good one to show you a bunch of different on conditions. So keypad 2 starter is equal to 1 and neutral safety is equal to 1. So if we hit the starter button up overhead on the roll bar, but the neutral safety is not equal to 1, then the starter won't work. If we hit the bump start button and the neutral safety is not equal to 1, then the starter is not going to engage. The neutral safety has to be equal to 1. So both of those are two different they're two different on conditions, but both of them require the neutral safety to be equal to 1. So hopefully that makes sense. Now let's look at a flashing output. So let's look at the right turn. So the right turn, now notice the output function is set to flash. Our flash on and off time is 0.5 seconds. Okay, so that means that it turns on for half a second and then turns off for half a second. We look at the on conditions for that, and we have KP2 right turn is equal to 1, right? So if we press the right turn switch, it's going to turn on the right turn signal. Or if we press the hazard switch, it's going to turn on the right turn signal. So there's no need for us to have an additional output for hazards when we can just use the one output for hazards. If we look at the left turn signal, where are you? Right there. And go to on conditions, the KP2 left turn or hazard. So when you press the hazard button, it turns on both of them, right? Oops, cancel. So hopefully that makes sense on how to do that, and kind of gives you an idea of how to look over or how to set up a Smartwire. Last thing we'll look at is if you are using an EFI CAN module. Let's look at the transmission fan, or actually, yeah, let's look at trans fan, right? So right click on trans fan, it's constant on output, fuse current's 20 amp, go to the on condition, KP2 trans fan's equal to 1. So that means that if I press the trans fan switch on the keypad, it'll turn it on. The next option is that EFI trans temp is greater than 100, keypad 2 ignition is on, and engine RPM is above 500. So we don't want the fan to just run when the key on engine off, right? So because there's no fluid being pumped through the cooler, so trans temp's got to be over 100, ignition's got to be on, and engine's got to be over 500 RPM. So that's how you pick up the CAN bus information from the CAN module. And in order to look at that, let's look at the EFI trans temp input side from the CAN module. So we right click on that. We set the scaling to match our scaling for the trans temp sensor, so 0 to 300 degrees. We have this set up to IO input number 5. This is where it's a little tricky, right? So if we look at IO input number 5, if we go here and look at input, notice it's at actually number 6. So it's one number off. And the reason being is that it starts at input number 0, right? So like 0 is 1. It's a little goofy, but just know that you're always one number over, right? So trans temp is here. It's a thermistor. And we got 302 degrees. So when it sees that, when the Racepak sees that the trans temp is over that set point, it turns on the trans cooler fan. And we can look at gear position. We can look at that one too, right? So reverse lights. Where is reverse light? It's right there. So on condition, again, EFI gear position is greater than 0.7 inches and less than 1.1 inches, right? And the ignition is on. Now the reason this needs to be played with to figure out where your gear position is. I made another video for Just Holly software explaining how to figure this out, so watch that if this is something that you're interested in doing. But it's greater than 0.7 inches and less than 1.1 inches, and the ignition is equal to 1. We can throw another caveat in there so that the reverse lights don't come on unless the engine's running also. So, if we wanted to, we can do this. We could say EFI engine RPM is greater than 500, right? And then we can right click and hit greater than 500. So now if we scroll over, so now the EFI engine RPM has to be over 500, ignition has to be on, obviously. Gear position has to be less than 1.1 and greater than 0.7. So now the reverse lights are only going to come on when the engine's running and you put it in reverse. So pretty neat how it works. It's It has a lot of flexibility, a lot of tunability with it. This is why we use it. They've been bulletproof. I've got quite a few years on my own personal one, plus all the countless ones that we've put in customers' cars. So if you're considering rewiring your car, give Smartwire a look, and let us know if we can help you with anything. All right, have a good one.